Okay, so I got cut off on my last video, but we'll finish up with dividing complex numbers. And before we talk about uh, dividing, we first have to talk about what is it a complex conjugate, because we're going to use this idea in dividing complex numbers. So with the complex conjugate, basically the definition is if a plus bi is a complex number, its conjugate is a minus bi. Basically, you just take the imaginary part and change the sign of just the imaginary part. So, for example, 4 plus 2i is a complex number. Its conjugate is 4 minus 2i. If I have 7 plus the square root of I, square root of 7, it's going to be 7 minus I, square root of 7. If I have 4i, its conjugate is negative 4i. If I have I plus 3, again, just change the sign of the imaginary part, so it'll be negative I plus 3. That one's just switched around a little bit. Okay? So, why do we need that for dividing? Well, here's the definition of how to divide complex numbers. When, this is a long definition and it's wordy. When dividing complex numbers, multiply by 1. That 1 being the complex conjugate of the denominator over itself. Okay, so let's do a couple examples. That's kind of confusing, but it makes sense when you see an example. So here's a really simple division with a complex number. It says take the denominator, okay, and we're going to multiply by the conjugate of the denominator, which is negative I, over itself. So on top, we have negative 7i. On bottom, we have negative I squared. And that's why we multiply by the conjugate, is because it will make the denominator a real number. So this is negative 7i over negative 1, which is just 1. So the answer is negative 7i. Okay, another example. Let's say I have 2 plus 4i over 1 plus I. Okay, looking at just the denominator, its conjugate is 1 minus I, so we're going to put 1 minus I over itself. Okay, use the distributive property. On top, we're going to have 2 minus 2i plus 4i minus 4i squared. On bottom, we're going to have 1 minus I plus I minus I squared. Combine on top, I have 2 plus 2i, and that's going to become plus 4. On bottom, you can see that these two guys completely cancel out. And this over here becomes plus 1. So we have 1 plus 1. So on top, we have 6 plus 2i, and on bottom we have 2, which is just 3 plus I. Okay, that example worked out nicely. End up with another complex number. And our last example is 3 minus 5i over 4 plus 3i. Again, denominator. That's going to be 4 minus 3i. So put it over itself. On top, distributive property, 12 minus 9i minus 20i plus 15i squared. Bottom, 16 minus 12i plus 12i minus 9i squared. So on top I have 12 minus 29i, and this becomes minus 15. On bottom, again, these cancel. So I have 16 plus 9. So I have negative 3 minus 29i over 25. And that's a good answer, but if you want to put it in standard form of a complex number, we'll just put that denominator with each piece. That 9 looks kind of gimpy. So there you go. Okay, I'm going to stop there.